content. This is where we have our syllabus, and your syllabuses are exactly the same. That's why I can have you all come together for this thing. So it breaks down, what the course is, our learning outcomes, the requirements, our grading scale. So you can see our intro quiz, less than 1% of your grade. It does not mean a lot. I am 100% using it for attendance purposes, but a good way to also make sure I can answer anybody's questions. And then you can see we have 4 projects, right? And that's each project is 15% of your grade. And then we have our midterm and our final. So 2 tests, 4 projects is what is on the syllabus. Now, I do give you a choice here, and we'll get to that in a minute. But if we were in the classroom, this would be exactly what we're doing. Because we're not in the classroom, I'm going to give you an option because some people's anxiety skyrockets a little bit for projects. So we'll talk more of that in a minute if you don't want to do the projects. But our grading scale, that's just the default CM grading scale. I just literally copied it from what CM said we should use. So that should be, hopefully all instructors are using that, but I doubt they are. And then our breakdown. So you can see week 1, we're going to do chapter 1, critical thinking and problem solving. A lot of definitions, kind of talking about what the course is going to be. Not too much into that here. Good news, not real math heavy. So if we were just still not a fan of math, works out in your favor in that aspect. But you can see, we basically, first 2 weeks, we cover 1 chapter a week, and then we slow things down. And then we basically take 2 weeks to cover every single chapter. And the first test will be over chapters 1 through 4. The second test will be over chapters 5 through 9, not include 6. So basically 4 chapters per each test, right? And we'll talk the test more closer to the time that they come. But there is the test, and then there's just a PDF copy if you want to download and print it for your own files. Any questions on anything that was on the syllabus?
Are you going to talk a little bit more about the projects?
Yes.
Okay.
And let me see. All right. All right, so then let's go to, so I broke our course down into 2 blocks. So block 1 takes us all the way to the midterm, right? And then block 2 is everything after the midterm. So block 1, you can see we have our welcome quiz, right? And then we have project 1 submission and this little discussion thing here, right? Discussions are not graded, they're not required. I just like to put them in there because it is another way that we can communicate. You may email me and ask me questions. The problem is most of you like to do your work late at the night. I'm retired Army, so I still get up early in the morning. So you'll email me sometime after 9, I will not answer. And I'll answer somewhere about 5 in the morning because that's what time I get up. So if you want instant feedback, I highly encourage you to use the discussion because maybe you'll get lucky and there will be a fellow classmate doing work at the same time. Maybe they can give you some pointers. But either way, that's what the discussions are for. They're there to ask questions and kind of communicate with each other. But you can feel free to email me or even ask me in the discussion as well. Completely up to you how you do that. And then we have our projects. These projects are meant to be intro projects, right? So that there's not a lot to them as far, I don't want you to think of the projects like a thesis or a research paper, right? That's what I get a lot of fear of. The way I do my writing, and I love my humanities friends, but they would probably yell at me for this. I want your papers to be short, right? Because in real life, no one has time to read a 20-page paper, right? So they need to be to the point. These projects, I don't expect them to be two, maybe 3 pages. They should not be any longer than that, right? So not looking for some crazy thing. If you plan on taking statistics, and if you like my teaching style and you plan on taking statistics with me, no, there is a bigger project in my stats course. So if you don't like the projects, then definitely don't take stats with me because that one's not optional. But if you want to see how statistics is applied in the real world, then I would encourage you to take stats with me. I teach stats very different than any other instructor here. And I think students know that. And that's why my stats class seems to fail quickly because I take a different approach. That is my degree. My degree is, I have a master's in operations research, which is basically taking statistics and math modeling and making predictions. I'm an overpaid fortune teller. So that is kind of a combination of this course and statistics is what I've done in real life. So I teach it how I've done analysis. I can tell you of all my years of doing analysis before I started teaching, no one has ever asked me to solve an equation. No one has ever asked me to do these calculations. Instead, they've said, solve this problem using math. So that's what I'm going to teach you all how to do. And in reality, 90% of you will never do that, right? So what you're going to do is you're going to have to actually interpret someone else's results, right? If you're nursing or human services, someone else is going to do some kind of analysis, and then you're the one stuck explaining it, right? And this is how I always argue why statistics is important to my nurses and human services, right? If you're a nurse, doctor comes in and says, hey, this is the procedure I'm going to give you. This is when we're going to do it. This is the tape we're going to do it. Any questions? No, good, I'm busy, bye. And then who's standing there? The nurse. And then the patient looks to the nurse and says, how likely is this the thing? What are the side effects? What are all this? And you're the one left explaining it all, right? And that's where statistics comes in, right? What's the chances this happens? What are the, that's, so interpreting someone else's results is what most of you are going to do for statistics. You're not technically going to do those crazy calculations, but you need to understand what they're saying. And more importantly, you got to know if they've wrong, right? And by understanding statistics, you can quickly read someone's analysis and be like, these people made a huge mistake, right? And that's what we're going to spend this class learning, as well as how I teach my statistics class. So we're going to get technology to do calculations for us, and we're going to interpret results, right? And that's how I teach. So that's why I think my class is filled, because a lot of students like that methodology better than doing math on paper. Anyway, I digress. So our projects, please, the whole point of that whole rant was to know that they're not overwhelming. I give you two choices. There is book projects, which are straight from the book, right? So I'll open that document. And then there are instructor projects, ones that I came up with. So I'll also download that one. So we'll open the book one first, because that one seems to be the least overwhelming. New share, book projects, share. Right, and these are literally copied and pasted right out of the book. I made no edits to these. So each chapter has its own project. You have to pick two. You can pick two projects from the book. You can pick two of my projects. You can pick one or the other, or you can do something totally different, which we'll get to in a minute. But if you're going to do a project, that's the key. You have to pick two. And again, which two you pick, I don't have a preference. There's no bonus points for picking mine or picking the books. It's literally pick two. Most of my students, after teaching this for a little bit in the spring and then 2 sections in the fall, almost every student who does projects does the Dream Plans project. It is a very straightforward project. A lot of students seem to like it. This project asks you to build your dream home. If you are going to open your own business, then if you want to tweak this to be open my own business, I am completely fine with that. I am very flexible with the projects. But it goes through what chapter 1 is, which we'll talk about today, right? Step 1, what is your problem? Come up with a plan. How will you carry out the plan? Look at what are your initial thoughts about your plan. List 2 things you could do better. No math even involved in any of this. It is literally, how do we use analysis to solve a problem, right? So that is that problem. And so this is why most students like the book prop things, because they're very scriptive. It's going to say, answer these specific questions. So it is, I call it a project, but it's really an overblown homework assignment. Project 2, which is probably the next popular project that these students do, is we create a truth table. A Venn diagram, which we haven't learned yet, but we will, but that's chapter 2. And what you do here is you come up with a survey, and you ask 50 people 3 questions, and they want it to be a binary response, which means that your question needs to have a yes, no answer, all right? So you come up with 3 questions. So here's some examples. Most students use these 3 questions. I would encourage you not to use these 3 questions. These are just examples. You can ask any 3 questions you want. I had a student last class who her question was, do you wear a face mask in public? So if you can ask whatever questions you like, you just need 3, because we got to build a Venn diagram. And it's what has this table right here. So when you create your table, your titles are the 3 questions. And then your responses, they already have this. So if someone says yes to all 3 questions, then that goes there. So say you interview 50 people, 20 people said yes to all 3 questions, and you put a 20 there. Now, these 3 boxes better add up to 50, right? Because you can't double count anybody. And again, if you don't understand this concept, it's okay. That's chapter 2, but we'll get there. but this is just come up with some questions to ask. And then this is what a Venn diagram is, and I'll teach you how to build it and do all that cool analysis. And you actually do the problem twice, right? So you ask 50 people, then you ask another 50 people. So you end up asking 100 people. What she did is she just got on Facebook and said, hey, Facebook friends or Twitter, whatever social media you like to use, you can create cool surveys, and they should just ask them. And she actually got way over 100 responses, right? I've yet to have anyone do this project. Keep the lights on. This is very electrical engineering truth table, kind of a cool project, but that's about truth tables. And we'll learn about those in chapter 3. Again, very scriptive in the questions. And then quite a few students do this problem using proportions and ratios on college tuitions, right? So there's the 4 book projects. You must pick 2. You can do all 2 from here. You can do 0 from here and instead do the instructor problems. So let me find which one I want now. I'm closing everything instead of open what I want. Oh, I didn't download it. Brightspace, where are you at? There we go. Instructor, open file. New share, instructor projects, share. So projects I came up with, and I think there's only 3 on here. Yes, so even if you, so one of them, and I've had one student do this, solve a Rubik's Cube, right? There is an algorithm, a logic to solving the Rubik's Cube. If you're in the classroom, I'd bring my triangle one in. I can typically solve the triangle Rubik's Cube in about 2 minutes. So I have not mastered the 3x3 yet. Hopefully that'll be able to do that one quickly one day. But one of the projects is solve a Rubik's Cube. And you can even cheat. You can even go to YouTube and see how to do it. Because you're going to talk about the algorithm, the theory behind solving it. And you don't even have to write a paper on this one. You can actually record yourself doing it. I have had one student do this project. So that is an option. Another one, and this is probably the most common one for my projects that students pick, is the social media one. Create 2 statements comparing social media platforms. And again, you might not know what a statement is. We'll get to that in chapter 3, but you're going to come up with 2 statements and you're going to create a truth table. Very similar to the lights project in the book, right? But instead of using lights, we're going to compare social medias, right? And then write a 2 to 3 page paper, including these concepts from chapter 3. And then the last one is do college tuition analysis. Again, very similar to the book problem. However, I have mine in an Excel file, and that's why that Excel file is on Brightspace. That Excel file is specific to solve this project. So you use Excel to assist you doing proportion or ratio solving analysis. So 7 projects to choose from. You must pick 2 out of the 7. All right. That's if you want to do the projects. Questions on the projects? Okay. So let me go back to closing those out. I'll ignore that. Oh, I got a chat. I saw a chat pop up. Not this time. Thanks, Zach. So new share screen. Go back to Brightspace. All right. So we're done. So content. So that is what's required there. And then when we get to block 2, there's a whole different set of 8 projects, and then you pick 2 from those for projects 3 and 4, and we'll talk more about that later in the semester. If you just do not want to do projects, and I've already had a couple of you email me that just like, nope, my anxiety is too high. I'm not doing projects when I can't ask for help. Then you can do Hawks, right? And Hawk software should have come with your book. And so is the issue with Hawk. So please interrupt me if there's any confusion, because this is going to get confusing. Last semester, I said you could do all the Hawks instead of doing projects. And what ended up happening in the end, there was way more Hawks work than the projects. The students who actually ended up doing Hawks probably put twice as much work in. And I felt bad. So what I've done is I've changed it to where you only have to do the chapter reviews. So you can see they're listed here. There's 8 chapter reviews. I know it says 9, but we skipped chapter 6. These are what you can do instead of the projects, all right? These are the only things I care about instead of the projects. You do not have to tell me which one you're doing, right? If you submit me projects, then that's telling me you're doing the projects. If you submit no projects, then I will go and see if you've done the Hawks, and I will pull Hawks grades instead of putting in project scores. If you do neither, then that tells me you just chose not to do anything. And then that also tells me what you do. So you don't have to tell me. I can tell by what you do, what you want to do. The issue, because I give you choices, well, we'll get to that in a minute. We'll talk about the issue in a minute. This is where the confusion comes in. So if I click on Hawks SSO, which all of you should do, even if you're doing project, what? All right, I get to figure out why that's not linked. That's an issue. And we'll go back and fix that afterwards. So hopefully this one works. Go to 01. Say, I swear I linked these things. Hawks SSO. Oh, maybe it's because I'm in learner mode and it doesn't know who I am. That's why, hopefully. But yeah, so if you're in section 02 and your Hawks is not working, please email me. I'll check the link too, but it might have not just let me in because I'm not listed in that class. I'm listed in the 01 class, I think, but I will double check it as well. If you click on Hawks SSO, this opens up the Hawks whole thing. So if you've used Hawks before, this is where it's going to look familiar to you. Now, if you've never used Hawks, then this is still just going to look new to you. I got 2 chats. Let me see this question. Okay, thanks, Chris. I will definitely figure out why my O2 is not linked and it will be fixed. When you log into your Hawks SSO, you can see there's 42 assignments due, right? I can't change this. This is a Hawks thing. I only care about the chapter reviews, right? But the reason I still have all these assignments in here is I would still like you to go in and do some of the Hawks, because this is where you get to practice things, right? So we'll go to thinking mathematically. So this is what we're going to learn today, right? So the way Hawks works, you have this learn. So this is a good place to go if I've taught the lesson for the week and you're like, he made no sense. I have no idea what the guy's talking about. Go here and it has some slides and it has some videos and it basically breaks the book down for you, right? Or if you missed the Zoom and you said, hey, I'm going to also go to this so I can learn some more. This is where it's like reading the book. That's what learn does. Practice gives you practice problems, right? So this says, is this sequence arithmetic, geometric, or neither, right? Haven't learned it yet, so you might not know the answer, right? But so this is where there's practice problems. I recommend that you only do the practice problems. The practice problems are because you can get tutoring. You can also email the problem to me specifically and say, hey, I have no idea what to do with this problem, right? This is where you can get try similar. This is where you can kind of get help, right? And because it's not being graded, I wouldn't waste my time. Go back to Hawks Learning. Don't do it that way then. I should have hit exit. Life Mac Academy. Certify is where you get graded, right? And if you're doing the projects, then you shouldn't do any certifies. If you're doing the Hawks, then only do the chapter review certifies. Can you do this certified? Of course you can. I can't turn it off, but you're creating way more work for yourself and you're going to stress yourself out. So use the practice, do a couple problems. Like, hey, yep, I understand the concepts. I'm good. Exit it, move on. The difference with certify is when you go in here, it looks exactly the same as the practice. There is no tutor. There is no email my instructor. There is no help. It is just answer the question. There is no reason to do the certify unless you want to be graded on it. And since I don't count any of the sections, there's no reason to be graded on them, right? The only ones that you have to, exit without saving because I didn't do anything, so if I go to view life mathematically, and if I click on, see, all these are marked as bonus. They're not bonus. Hawks doesn't let me change it to optional, right? But remind yourself, put it in your notes, the ones that say bonus, optional. They're just there for practice. The ones that don't say bonus, like the chapter review, these are the ones that you can do instead of the projects. So you're like, hey, I am not doing projects. I'm going to do the Hawks. Then you come in here. You still have the option to learn. You still have the option to practice, but you must certify if you want this to count as a grade, right? So that is the difference. If you're going to do Hawks instead of the projects, you must certify the chapter reviews. The other problems are just for you to practice lessons. Think of it as taking the book out and doing problems. If you don't like Hawks and you actually have the book itself, you could easily just go to section 1.1 and pick some odd numbers to practice and then look at the answers in the back of the book. That is kind of what I created here, is a virtual book for you to use to practice problems. But In reality, all I want you to do, well, in reality, I want you to do the projects. I think you'll enjoy them more. But if you don't, if they just make you nervous or you like Hawks, I've had some students say, hey, I've used Hawks, I really like it, then fine. It's there for you. Do the chapter reviews. Serena, question.
Okay, so explain it. So we have to certify prior to every chapter review or just the one time for it to count as a grade? I'm confused.
Just so when you use Hawks, so I'll go to my chapter review,
Yep.
right? It's like playing a video game. You have lives here. As long as that little heart never goes below 0, you're okay, right? So you answer the question so you can see there's 18 homework problems. You don't have to get them all right. You can miss 3 and still get full credit, right? So you have to get 15 out of the 18 problems correct. This is the issue with Hawks, and it does not let me change it. It is kind of a go, no-go thing. If you certify, you get 100. If you don't certify, you get a 0, right? And I can't change that. So what I tell my students to do, say you've done the chapter review 3 times and you keep missing 4 questions over and over again. You can't hit that threshold. Email me and I'll give you credit, all right? Because I don't want it to be a punishment. But please, because I will check. I've had students email like, I can't certify. And I log on and it says they attempted to certify for 45 seconds. I'm going to tell you to try a few more times, right? But if I log in and say, hey, I've been working on this, and I say, oh, yes, Chris, you have done the certify 5 times, and you've been working on it for an hour and a half, then yes, I will give you full credit, move on, right? I wish I could just let it pull a grade of how much you get right, but it is a go, no-go thing. But yes, the certify is all I'm looking for. Question.
The book correlates with the review. So we should read the chapter first. First of all, that's the first thing we should do. Read the chapter, go over the chapter, sort of know the chapter.
Cancel.
And then go on to the Hawks if we choose to take that route.
Yep. And then even if you decide to do the projects, I'm trying to figure out how to save and exit. Oh, there it is, save and exit. Lost my track there. Exit without saving because I haven't done anything. Even if you're doing, God, I did it again. Ugh. You can see I'm still getting comfortable with the Brightspace thing. Even if you are doing the projects, I would encourage everyone to do the sections, either through Hawks or like you said, pull out the book and just kind of look at a couple problems in 1.1, because there is still 2 tests, right? And so these will kind of give you an idea what kind of tests. And there will be a practice test that I will post for practice. So technically you could just do problems out of the book and just do the practice test and never even touch Hawks, right? So I do have an option so you don't have to worry about that. But I would still go in and do a couple problems each section after that week's lesson to stay on pace, right? So like the syllabus says, hey, we're going to get through chapter 1 in this week. So you can see there's only 3 sections. So sometime this week, you should go through those 3 sections and see if you have any questions and do a couple problems to see if you got the concepts down. If you do, great. Just either start project 1 or do the chapter 1 review and kind of be good to go. Zach, you said, how many times can you attempt to certify? As many times as you want. Now, there is a stipulation. If you fail to certify, I think twice, it's going to kick you to practice and it's going to force you to score at least a 50 in the practice before it reopens to certify. So that way you don't just keep running into the same problems that you don't know how to solve. It will help you, it will kick you back out and say, hey, you need some practice on ratio problems. So we're going to give you a couple practice of these before we let you back into certify. Yes. So does Hawks better to prepare for the test versus the projects? My answer is, in my opinion, it doesn't matter because you have to understand the concepts to do the projects. However, yes, the Hawks problems will look similar to the test so that you'll see kind of what the problems look like. However, since I post that practice test, you can still do the projects, then you can look at the practice test and say, okay, I understand these based on my project, or okay, questions 5 and 6 I don't quite get. And then you can kind of go look those up. So either one of you is going to help prepare for the test. If they're advantage slightly maybe to doing the whole Hawks because you'll start to see questions. So maybe a slight advantage on Hawks in that aspect because the questions will look familiar. But I do give you a practice test about 10 days prior to the test, so you have more than ample time to kind of go through and decipher some of those problems. Any other questions? The tutors, yes, good question. I'm working on that. So let me come back to the, well, we'll talk tutoring right now real quick. We're almost done with the software. So there's two types of tutoring, right? Everyone has access to tutoring in the Math and Science Center. I do not know of a tutor in the Math and Science Center that is comfortable tutoring this yet. I am working on that. I also tutor for the Math Science Center, so worst case scenario, then I can assist you. You know, technically I'm not supposed to, but because we don't have anyone, they're kind of looking the other way. If you're a trio student, yes, I have a tutor, a prior student who took with me and did extremely well. And he can also reach back when he gets stuck again. So Trio does have a good tutor for quantitative reasoning, as well as I also work for Trio. So I wear multiple hats. So I'll be there to assist. If you do not know what Trio is, talk to me and I can let you know of how you can possibly become a member of Trio. But you have free tutoring and it is a new course. And all honestly, anyone can tutor this, and I'm going to work with the Math Science Center on that. The only chapters I think most students, I mean, most tutors will struggle with are chapters 2 and 3, the logic chapters, because no one really tutors logic but me, even before we taught this. So there's a course called Numbers and Logic Math 102, which is basically our entire course on chapters 2 and 3. Like I said, we don't dive deep into anything, and there's courses that dive deep into every section that we go into. And I am the only tutor I know on campus that also tutors numbers and logic because I understand truth tables. So there is a small shortfall, to be completely honest. However, I will work with you in office hours. I will make sure you get the help you need, even if there's not a tutor. But Trio does have one. So if you're a Trio student, you haven't got an email from me yet, but you will, linking you up with the Trio tutor. If you're not a Trio student, I encourage you to apply. And you can reach out to me and I can tell you about that. But the Math Science Center, I will work with them. And I am working with someone in the Math Science Center to get them more comfortable with this as well. So that leads me into office hours. I have no set office hours because just like not everyone can attend this Zoom, if I create a office hour, not everyone can attend that. So the way office hours work is if you're stuck that week, email me and then we will coordinate a time to come together. And we're just going to use the class Zoom, right? So I'll say, hey, I'm available at 3 today. And you're like, hey, cool, me too. All right. I said, all right, 3, just click on the class Zoom and we'll meet, right? So don't worry about me sending you another link. It'll be just our class Zoom, but there won't be a scheduled time that I'm just sitting on Zoom. I tried that last semester. It was a waste of my time and never worked with students times either. So in this time, I'm just going to go the flexible method. You got to be a little proactive, which means you have to reach out to me. But I will find time in my schedule to, even if it has to be evening sometimes, we'll find time to come together to work through the concepts. I can tell you for anyone that does have anxiety about taking math online, nervous because this is a new math class and maybe things you've never seen before. I have never had a student fail my class who has put in the effort. Right? I've had students fail, but when you turn in no homework and you don't take the last test, then it's hard for me to help you pass. But if you do the work, it doesn't even have to be perfect. I've had students fail every single test and still pass the class with a higher than a C. Right? That's why I give you projects. I give you homework. I give you multiple options to show me what you know. Right? So the key is do something. Right? Doing nothing, as much as I appreciate it because it makes it really easy to grade, I can't help you either. Right? So, attempt it. If you can't certify, message me. If you're stuck on a project, hey, email me your project. Say, hey, I made it to this point. I am so lost. Oh, here, let me help you. Move this here, do this here, cross this out. Here, all fixed. Go ahead, continue. And you finish, right? So any students that stay the course will make it. All right, and I will work with you. I had a student who just had high test anxiety. She failed both tests. She said, hey, if I do some extra of the Hawks, well, can you give me some bonus points to the test? Sure. If you're going to put in that effort and find time to do more work to show me that you're dedicated, yeah, I'll add bonus points to your test for you doing the assignments. I will work with you. It just needs you to let me know what I can do to help you. All right, here are we at? Calculators. I'm a little behind where I want to be. That's okay. We're almost there. Get a calculator. All right. I know some of you love your cell phones. I don't mind you using cell phones, so I'm not going to say you can't. I've been told there's a policy, but I have not seen it anywhere that you can't use cell phones, so I'm not going to even go into that thing. However, I have tutored a student where they've done the math on their cell phone. I've done the math on the calculator, and their cell phone was wrong. And then he asked me why. I'm like, I have no idea. Like, I don't know who programmed your cell phone, so who knows if they're following the rules of math. I had no idea why you got it wrong. I'm like, it's just, I know it's wrong. So get a calculator. And so the calculators I recommend, and these are based on price, nothing more than price. So don't be like, oh, he thinks this is an awesome calculator, I need to go get it. No, it's 100% based on price. This is a good, cheap calculator. I think when I bought it, it was like $8 at Walmart, and I bought it last year. So it's not like I bought it 20 years ago. This is the FX 300E Plus. Walmart, Amazon, I think it was around 8, but it's definitely under 20. I really like this calculator because when you put in the information in this calculator, it looks just like it does on the paper. So when you use the fraction key, which is this little key that I have my mouse next to, it actually puts it in the calculator and it looks just like a fraction. When you use the square exponent key, it actually puts it as an exponent in the calculator. So I like this calculator in that aspect because it shows exactly like it's supposed to on paper. And it has every function that we need for our class. And this calculator will get you through every single math class that you take in college, not even at CM, all of them, right? Because even if you went to advanced calculus, they don't let you use the expensive calculators because it gives you the answer. They make you use the cheap calculators. If you take statistics, this is the same calculator I recommend to my statistics student. If you take pre-calculus, this is the same calculator I recommend to my pre-calc students. It is a nice $20 calculator that will do every calculation that you could possibly need, right? Right, just to show that I don't know preference, this is the calculator I started with here at CM. A lot of students have it. This is the one the bookstore sells, the TI-30X, another great calculator. And again, I think the bookstore sells it for like 22, Walmart's like 18, Amazon's like 21. Cool one. I've seen students get this in pink and purple and blue. So if you like pretty colors, another great calculator. Again, under 20 bucks, can do everything you need up to calculus. All right, so very cheap calculators. You do not need to go buy the expensive TI-84 fancy graphing calculator. If you have it, great. I'll teach you how to use it, but not required, right? And it's not, if you need statistics, this calculator will also get you through statistics. But just get a calculator because there is some crazy keys that we will use a little bit in this class. However, if you take statistics, your cell phone will not work in statistics because there is crazy keys that we use, and those crazy keys are built into both of these calculators, right? So get these, they'll make your life a lot easier. But don't go crazy, please. Again, if you want to go get the fancy TI-84, go ahead. However, it's like using a computer. So if you're not comfortable using your calculator, then it's useless to you. So make sure you get a calculator, always use it, so you get comfortable using it. So there's my 2 cents on calculators. Another thing that we will use, so where am I going? Office 365. So we will use Excel. You're not graded on Excel. This is not an Excel class, but I will show you how to use Excel because Excel can make your life way easier, right? And we'll use it for statistics too. And it's free to students. A lot of students didn't realize this. I even had a poor student last semester that said, oh, I bought it from the bookstore, which really frustrated me that the bookstore sells this knowing that it's free to students. If you go to Office 365 and you log in using your student email and your student password, this is what you'll see after you log in, right? And you can see you have access to all of the Word functions to include your email and to include OneNote, which we'll get into here in a minute. What I recommend you do is you come over here to the right and you click on Install Office. If you click on Install Office, you can actually download Microsoft Office to your computer where you'll have Microsoft Word and Microsoft Excel and Microsoft PowerPoint as a computer application on your computer. Can you use the apps here on the left? Yes. The issue is when we get into some of the advanced stuff I'm going to teach you in Excel, it doesn't work well in the app. But if you have it saved to your computer, it works extremely well. So I encourage all of my students, especially since it's free, to install it. Because Excel, as you're going to learn from me, it is in a fancy calculator. And I will show you all the cool calculations it can do. And it builds really cool graphs, really easy, versus building them by hand. And so if you take stats with me, we will definitely be doing a lot of this with stats. So good way to start to get comfortable with Excel. And that's how you get it for free. but also it gives you access to OneNote. And if you have the new Windows, I guess that comes as a default app, so you don't have to go through this whole process. However, I still recommend it because it just makes your life easier. And what I haven't done, which I need to do, I just remembered I haven't done this with you all yet. So I will fix that. I forgot to do that today, sorry. I don't know if the link works on Brightspace. Let me see real quick. I'm gonna go back to Brightspace, content, resources. Oh yeah, so that's what I forgot to talk about, resources. So I have YouTube videos of longer lectures, right? Because we only meet once a week for 90 minutes or so. And we're supposed to technically meet twice a week for 90 minutes or so. So I have less time to teach. I have videos I've done to help expand on some of the knowledge. If you click on this, it takes you right to my YouTube channel where I have a bunch of video lectures pre-recorded. What I don't know, which someone can let me know, and if not, I will send an email afterwards. You can get access to my notes on OneNote by clicking that link. Hopefully it works. If it does not, I will send everybody an email as soon as class is through with a email link that does work. And what that will do is bring you, no, I don't want to do that one. QR. It will bring you to my lecture notes for the entire semester. So all my notes that you will need for the semester. So hopefully that link works. If it does not, I will send out a link in the email that then you should work. And you can see I have all the chapters here. I have all the sections under each chapter. And this is basically how I am going to teach this in this online classroom. You will have access to my notes. You can't edit my notes, I hope. And you can download them to your OneNote, and then you could edit them. So if you want to be able to type in the notes, comments for you, you can print them and handwrite them if you choose, or you can just wait before the test and wait till I have updated them all and hit print. I don't care, but you have access to all of my notes that I am going to lecture on using my OneNote, all right? And like I said, that link should work. And someone said it worked for me, so perfect. The link works. And now we're a little bit past where I wanted to be because I spent 45 minutes talking in the class. We're actually going to get into chapter 1 now, barring any questions.
I just had a timing question.
Yes.
So it looks like Hawks is not timed. That's
Nope.
correct.
Nope.
And then how are your tests? Like how are the exams? Like
They're not timed. So because of the format, what I do is I'll open it up for a week. And I don't think they're timed. I don't believe they're timed. I believe I got it so you can't save and come back though. So once you start it, you got to finish it. But they're not timed. Just because we're online, I've tried to make my tests still be 90 minutes, like if we were in the classroom. So I didn't make them harder because we're online. I can't remember how many, it's like 20 questions or something, and not what I say overwhelming in my opinion, but students may differ with me. But they're meant to be 90 minutes. And I open them up. I know there's a lot of teachers that proctor and do all that stuff. I tried that one semester. It turned out to be a nightmare, and it ended up costing my students way more money than it was worth. This happened to me last fall when we had to use last spring when COVID happened and we went to ProctorU. It turned into a nightmare. And then ProctorU ended up charging my students like $35 to take my test, and I was not thrilled with that idea. So I got rid of it. And my argument on cheating is if you have to cheat to get through Math 115, you're not going to make it through the advanced classes, so it's going to catch up to you anyway. So it is open book, open note, open time. I mean, most of you are not going to be mathematicians, so I'm not really concerned, right? I'd use this, especially my nurses. I definitely wouldn't cheat to get through Math 115 because it's not going to help you because that program is enough to kill you. So just do your best. Nothing's timed.
Thank you.
Yep. Any other questions? Perfect. All right. So thinking mathematically, right? And I'll think that is we do this on a daily basis, right? And if we were taking algebra, my argument with algebra is students always tell me I never use algebra. Well, the reason is you think you never use algebra is because how we teach it, all right? And I argue, I'm not a mathematician. I'll say that right now. I am not a mathematician by trade. I am not a teacher by trade. I didn't go to school for that, so I have not been taught lesson plans and all the stuff that I probably why I argue with my fellow instructors at times of a difference of opinions. So I don't teach the aha, I got you. I don't teach that I know how much I know that you don't know. We use algebra every day in our lives. And the reason we don't see that is because that's how we teach it. And again, this is a completely my opinion, right? Because all algebra is solving for the unknown. We do algebra every day when you get out of bed and you decide what time to leave your house to get to where you're going, right? You could easily get to class on time if you left your house at 2 in the morning, right? But be pointless. What you do algebra by understanding how long it takes, traffic, all these things you take into account to decide what time you leave your house. You're doing algebra. Just because you're not solving for the mysterious X in a linear equation doesn't mean you're not doing algebra. And if we taught math that way, I think students would be more comfortable with math, right? So that's how I teach it. And that's exactly what this class is for. How do we use math to solve problems, right? And that's all it is, you know. So here's a little thing I want us to do to test my knowledge. And because it is math, we should do some math today. I want everybody to pick a natural number. And all a natural number is, if we forgot, is counting number. 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10, right? So you can't pick 0. Don't pick fractions, which I doubt any of you would, because who's going to want to do with fractions on the first day of math class? Pick a number, 1 to 10, right? Don't tell me what it is, right? So just tell yourself, pick a number 1 to 10. Now, take your number and multiply it by 2. All right. Now add 3 to that new number. Now multiply it by 10. So everybody has a new number, right? Okay. If your answer is even, your color is red. If your answer is odd, your color is blue. And I'm going to guess your color. All righty. Everyone's color is red. Am I right? Why am I right? Anyone know? Perfect, Shane. Yep, and David said too. I times it by 10. What does times something by 10 do? Yeah, 10 times. It ends in 0. And if a number ends in 0, it is even. Right? So these are the tricks that sometimes you see them on Facebook and all these, you know, whatever the cool hot TikTok and all those fancy social media fun games where they guess your thing. Like, how did they do that? They're using the rules of something to make a prediction. And all those steps in between are just to make you think you're in control, right? But the last step put me back in control. And I knew multiply anything by 10 ends in 0, anything that ends in 0 is even. And since I said even colors are red, I can guess everybody's color is red. Now, if you didn't get red, you made an arithmetic mistake. So make sure that you remember your rules of arithmetic, or again, buy a calculator. But that is thinking mathematically. I've come up with this cool puzzle. And that's where my Rubik's Cube problem comes in. The Rubik's Cube is actually solved by an algorithm, right? And the triangle is one of the easiest Rubik's Cubes to solve once you understand it. And there's really only 2 steps to solving the triangle the cube. Well, I guess it's not a cube. The triangle puzzle, I guess is the proper name for it. There's only 2 algorithms, only 2 math steps. And once you know those 2 math steps, I can solve it no matter what. I can go to anyone, they can mess it up. I am going to do the first algorithm, the first step over and over again until I either solve it, or what they call snake eyes or Spider-Man eyes. And if my triangle turns into Spider-Man eyes, I do a second algorithm and I solve it in 6 steps. And that's why I can solve it every single time, no matter what, because I know those 2 rules. The 3x3 actual original Rubik's Cube has like 3 different algorithms, but once you know the 3 algorithms, then you can solve it. Now, it does take practice because remembering the moves of the Rubik's Cube, but there is a math problem there. It is thinking mathematically to solve the problem, right? Solving this COVID problem is a math problem, right? Now, is there science involved in it? Of course there is. Is there rules of society and personal and all this other things? Of course there's. That's what makes it such a hard problem. If it was just one thing, then it would be easy to solve, right? But there is a science to the problem. There is a math to the problem. There is also a social aspect to the problem, which is why it has become a very challenging problem to solve, right? But there is a solution to this problem if we apply what we know about it, right? And when it first started, everybody talked about flattening the curve. Well, that curve was what we call a normal distribution, which we'll learn. I don't think we learn it. No, we don't learn it here, but we learn it in statistics. Oh, we do learn it here. We talk about it here too. And that's what we're trying to get. The problem is we have yet to create a normal curve, and hence why we have not solved the problem. It needs to become normally curved so that we can use the math that we understand to solve it, and we haven't created that yet. So hence, we're still fighting this problem. And so when we go through this, there's types of reasons, right? There's deduction reasoning, and there's inductive reasoning. Deduction reasoning is just that. I am using past knowledge to solve the problem. I'm using something I know, all right? And so my problem, what we just did with the color problem, it was deduction because I was using the rules of arithmetic. I was using order of operations. And by understanding mathematical order of operations, I could predict your color. I use deductive reasoning. I use past knowledge to get it. Inductive reasoning is where I take a past experience and I make a assumption of what it's going to kind of be. And it may be true and it may not always be true, right? But I'm using past knowledge to do it, right? So inductive reasoning kind of uses a counterexample, right? Sometimes proving what you want is hard, but if I can prove the opposite is not the case, then therefore, then I can prove what I'm looking for. And then, or it might be what we call these two sequences. So if you remember about an hour ago when I brought up Hawks, there was a problem asking, is this arithmetic sequence, a geometric sequence, or neither? We finally got to that material to answer that Hawks question. And all our arithmetic sequence is adding or subtracting the same number over and over again, right? And a geometric sequence is multiplying the same number over and over again. So some examples of reasoning. 2020 is a leap year, so 2024 will be a leap year. Why is that deductive reasoning? Anyone know?
Past knowledge.
Yeah, using past knowledge. Exactly. It happens every 4 years, right? We know there's a leap year every 4 years. So that is deductive reasoning. We know that's the case. I will get an A in this course if I attend every class. So that one would be inductive because you're assuming because I'm attending every class, I'm getting all the knowledge I need. So therefore I will get an A. It's not a guarantee. All snow days were on Tuesdays during the fall semester. Therefore, all snow days will be on Tuesdays during the spring semester. And this happened, this would have to be students who've been here for a while, but I think it was my second year teaching here. Every single snow day was on a Tuesday one semester, like by clockwork. We only had snow days on Tuesdays for some reason. But it's again inductive reasoning because who knows? Yeah, wishful thinking, exactly, right, Zach? So it is inductive reasoning. So now let's talk about these sequences. So I have 4 sets of numbers. And I'll give you a minute and please feel free to talk to each other. This is why I wanted mass attendance and it's good to see we have quite a few people here. And for examples, and see, is it an arithmetic sequence? Is it a geometric sequence? Or is it neither? And there's a couple tough ones here, I ain't gonna lie. But so the first one, is that a geometric? So remember, an arithmetic sequence is when you add the same number or subtract over and over again. Because add and subtraction are the same thing. We don't teach it that way, but they are just adding negative numbers. So it's adding and subtracting the same number and over. Geometric is multiplying the same number, and division is just multiplying by fractions. So they're the exact same thing as well. So example 1, arithmetic, geometric, neither. Anyone?
Would it be geometric because you're getting the numbers by their prime numbers, so it's a product.
Perfect. So no, prime numbers aren't product. What are prime numbers?
A number that's like where the only two numbers that multiply together are one in itself.
Perfect. So that's where the product comes. I see what you're thinking. But exactly. Good. Nice work. Notice that's prime numbers. That is the prime numbers. And by definition, a prime number is only multiplied by one in itself. So it's neither, because it has to be a product, which is true, but it has to be multiplied by the exact same number over and over again to be geometric. So it had to be always multiplied by 2 or always multiplied by 3. So that would make something geometric. So this one's neither because it's prime numbers. So that's neither because it's prime. Nice work. What about the next one? So this one is neither too. Neither. Our handwriting's always horrible, but it's even worse writing with a mouse. So, anyone with example 2? First 2 are the hardest. I started hard and went easy. I should have done it the other way, done easy, went hard. I'll let you know, this one's neither. It seems like it's 1, and it does have a pattern, but it's not geometric just because it has to be by the same ratio. So it is another product problem, but it's not the same ratio. And what this is it's a cubic problem, because 1 cubed equals 1, 2 cubed, I can't write a 3 with my mouse. 2 cubed is 8, 3 cubed is 27. So it is a combinations of cubics. So it is a pattern, but it is neither as well. All right, example 3. Now we're going a little better here. What about 3?
Is it adding 2 to each number?
Perfect. I am adding 2 to each number. So since I'm adding the same number over and over again, it is arithmetic. So arithmetic is example 3. Example 3 is an arithmetic problem because I am adding 2 every time. 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 2 is 7. 7 plus 2 is 9. So perfect. All right. Example 4.
Would this one be with the exponent of 2?
Yep. So this is multiplying exponent by 2 or multiplying by 2. Both are correct. But by multiplying by 2, I make it a geometric. So this is example 4, right? Because 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. Nice. And I see Tanner got the right answer as well. Good job. So I wish you were in the classroom. I've yet to do this class in the classroom, but one day I hope to, because what this class is supposed to be is actually what I call project-based group learning. If we were to actually come into the classroom, I would have had the tables arranged that each one of you would have been in groups, and I would have had the groups kind of come up with their own problems next. So that's how I would like to see this class learned. But we have yet to get there because of our lovely 2020, we'll call it that. Any questions on 1.1? 1.1 is, again, just how we think mathematically, seeing the math in problems kind of thing. That's kind of what we're looking for here. 1.2 is problem solving. And so there's this cool pattern in the book, and I've seen it other places too. So the author didn't just invent this, but this is, they call it the George Piola problem solving method. And we do this on our own without even realizing it, right? So when we go to solve a problem, the first thing we need to do is identify the problem, right? It's hard to solve something if we don't even know what the problem is, right? So we got to identify what the problem is, and that's step one. And then we should come up with a plan, right? And then when we come up with a plan, right? And then you execute the plan. And then after you execute, you look back, you should look back and be like, did we actually do what we wanted to do here, right? And if we did, then great, we're done. If we didn't, then we should probably go back and look at what the problem was and see if we actually solved that real problem, right? So this is kind of this 4-step model. And so where it comes into, and this, I'll try to find the link again and post it. I used to post it on before we were on Brightspace, but there's a TED talk about how we spend so much time on teaching step 3, how to do calculations, and we don't spend enough time on steps 1, 2, and 4, right? And because that's how we teach math. And my argument is, I agree with this TED talk, we shouldn't teach the math. We should spend less time on step 3 and doing calculations by hand, and spend more time in how do we properly identify a problem, how do we come up with a plan, and then how do we use math as a tool to solve that problem, right? And that's kind of the things we're going to try to get to in this class, and learn how to use math to solve our problems. But step 3, executing the plan, that's when we apply the calculations. That's where we apply the reasoning, the deductive and inductive reasoning, and executing our plans. And then we look back and do we actually solve the problem, right? And I think a lot of times people don't do this. And honestly, this is why I stopped doing this in the real world. There was many times I've done the math for a problem and I presented it to who I was doing the analysis for. And I don't know how many times I got the answer back like, ooh, that's really hard. I'm like, yes, but this is what you need to solve the problem. And then like, well, can you just change the numbers so it works? No, the numbers are what they are, right? The numbers are it. Like, you gave me the data. Changing the data creates a whole different set of circumstances. I'm like, no, we're not going to do all that. Instead, we're just going to do this. But that doesn't solve your problem. Yeah, but at least we did something, right? We don't follow this in the real world because people don't like the answer that they get. But that's why we don't typically solve any problem. And we see this all the time in government, and not picking sides in government, but there's a lot of times where we've done things and we've thrown money at it. Like that's the government's big response to a lot of problems. Like, just if we throw more money at it, the problem will fix itself, right? And then we've learned it doesn't work that way, right? Because there's that point where you just start throwing money at a problem and you're wasting money now because it's not actually, you're not getting what they call the bang for their buck, right? In the 90s, late 80s, early 90s, to attack the drug problem, they said, okay, what we'll do is we'll send everybody to jail that uses drugs, and no one wants to go to jail, so therefore everybody will stop using drugs. And what had happened was that didn't solve our problems, and all that did was create a new problem. We've overpopulated our jail system, right? So we know this step process, we learn this step process, but we don't do step 4. We don't look back and say, did we actually solve the problem, right? And most times than not, we don't. And that's what this math class tries to get to, is not worry so much on the calculations, but did the calculations help us? And if they didn't, why, right? It's not the math that's wrong. And I get that a lot when my students, I'm in the class, my calculator gave me the wrong answer. I promise you, your calculator did not give you the wrong answer. Your calculator might have the wrong answer on it because you put something in it wrong. Again, you didn't execute the plan. You didn't look back to make sure it makes sense. And we see this a lot in this class in probability and statistics. The one thing I always tell my students in probability and statistics, you can't have a value greater than 1. You can't have more than 100% in probability and statistics. And then I will get an answer that's greater than 100%, and the student will still submit it. And I'm like, why'd you submit this? You know it can't be greater than 1, so you know your answer was wrong. Why don't you try to fix it? Well, I didn't know what else to do, so I just gave you an answer. Right? We're not looking back, and we're not seeing what the problem is. So a kind of cool problem that I always like to do. And so how are we doing on time? I think we're okay. So it's kind of another, like my problems. It's called like this magic square, right? So we have some missing numbers, and I already told the numbers that are missing. We're missing the numbers 2, 32, 37, and 42. And there's 4 boxes there. And I want to know where those numbers go. And so how magic square works is when you add up the rows and you add up the column and you add up the one large diagonal, you get the exact same value every single time, right? So when I add the numbers across, when I add the numbers down, and I add the numbers at the diagonal, all of the numbers equal the same thing when I add them together. Give everybody about 4 minutes because we're a little tight on time. See if you can finish the square. And then I will work it with you as well. And then we'll talk how you attack this problem, right? So identify our problem, complete the square. Now you come up with a plan, and we're going to see how our plans differ. Yes, very similar to what Sudoku is, right? So the only difference between this and Sudoku is you can only use the numbers 1 through 9, and they have to match up in the small boxes as well as the big box. But it's very similar to Sudoku. And I'm a math geek and I like playing Sudoku as well. How are we doing? All right, got a few more minutes if people need it. Still 11 of us in the class. Nice. All right, so Zach says he's got the answer. So he says 42 goes into this top piece. So let me write that down. So Zach says this is 42. All right. $32 in the right center. All right. Two in the middle. And then the only number is left is 37. So I'm assuming that you want that right there. All right. Anyone agree? I think Chris and Zach will, because they both kind of going together. So I got Chris and Zach both saying that they agree with this. Anyone want to, so this is the correct answer. Anyone want to share how they attacked the problem? I'm assuming some more people got the right answer, right? All right, Chris, how'd you get it?
Well, when you said that the diagonal added up to the same, I just took away what I knew was there.
Okay, so you added up the 3 numbers and you got 66? Perfect.
Yeah.
So he's like, okay, I know all of these have to equal the same. And since I know the diagonal, if I add the diagonal together, then I know what every row has to equal. And then I can use that knowledge to find the missing pieces. He used deductive reasoning, right? He took something that he knew and then applied that to find the other pieces. Nice. Anyone do it any other way? Yep, so Zach said he did the same thing, added up the numbers going diagonal to find it. Anyone go any other route? Not enough to share yet, huh? My goal is to get us all talking, right? It's a safe class because you're gonna see I make just as many mistakes as you do. So making mistakes is not a bad thing. So I hope we'll keep everybody going. But this is how I want to see the class going. I don't want it to be a lecture. I want it to be in person. And since we can't, we're gonna do as best we can to make our Zoom a open learning environment. So please always share your ideas because sometimes I'll explain things. What are other ways could you solve this problem? Guess and check. It is a method. I wouldn't recommend it, but it is a method, right? So you can do guess and check. One way I've done it and seen students do it in the past is I know I would look and see where 42 would go because that's my biggest number. Yeah, trying out different thing a long time. 42 is my biggest number, so I would apply it. I would know it wouldn't go in probably the row 27 or 22. So I would try it in the first row and then compare. I've seen students do it that way as well. Attack the biggest number and kind of feel where it goes to make trial and error a little bit less. But definitely, yes, the diagonal problem is the quickest way. And so that's why some students like this class and some don't, because they want me to teach them and like, hey, just teach me what I need to know. Well, one, that's not my teaching style. And two, it really doesn't work for this class and it doesn't work for statistics. And those are my two primary classes that I teach here. Algebra, yes, I can give you a step-by-step procedure that will solve every problem the same every single time, but this doesn't work. It really depends on what method you like. There is multiple ways to solve these problems. And you're gonna find in our class and in real world, there's more than one right answer sometimes. And it's frustrating when been taught math all our lives, like there's only one answer. No, there's only one answer when you do arithmetic. But when you use math to solve problems, there's more than one answer and some are correct. And so you can have more than one right answer. And so that frustrates students when they've been told that there's only one answer and they want me to show them that one way. And I can't because there is not that one way. There is a way. And I can easily show you another way that also works and maybe get a different answer. Here, you're not going to get a different answer. This is the one answer. But we will do problems where there will be more than one right answer. And so that does frustrate some of my students who really love math. And they get into this like, I don't like this because there's more than one right answer. But that's how it goes sometimes. All right, not much time left, but there's not really a lot to this next section. You can see I forgot to erase all my notes. Help if I go draw. So I included this, and it's really just about rounding. And there is some problems, and I don't care for how they do the rounding problems. But I understand it. And some people use math this way. So the key takeaway from 1.3 is understanding how to round, right? I think that's more important. So I have a little table I stole from the internet of, again, reminding us where numbers go. And so to the right, to the left, as you're looking at this, we got our normal whole natural numbers, so millions, hundred, thousands, 10,000s, thousands, hundreds, tens, and ones. To the right, to the decimal place, you have the same thing except for the ones, and everything ends in THS. So that's kind of how I kind of memorize this, right? If I'm looking something and it ends in THS, tenths, hundreds, thousands, 10,000ths, then I know I am small. I am to the right of the decimal place. If it doesn't end in THS, then I know I am to the left. And knowing where you're at is how you round, right? So using the number I got here, if I ask you to round to the nearest, I'm going to text instead of drawing because it's easier. If I ask you to round to the thousands, right? So let me put that in here so we have it as left in our notes, round to the thousands, right? So what do? I come to the thousands place, because that's where I'm rounding to. I look to the right, and I see a 3. So that tells me I round, what we call round down, right? And so basically means don't change the number. So I round this to the thousands place, and the answer is 2,000. So what if I ask you to round to the hundreds? What is our answer? Perfect. I think that was Zach. I jumped in the chat. It's 400, right? So you go to the hundreds place, you see you have a 3. You look to the right as a 6. 6 is greater than 5, so we round up. So we get 400. All right. What if we round to the can I help if I can type? Thousandths. THS.
3,000.
Yeah, so we're going to, this 3,000 becomes a 3. So what you do is you write all the other numbers because you not rounding those. I can put a comma in, I guess, make it look nice. 325, 365, 0.14, and then like Kimberly said, you go by Kimberly or Kim?
Kim.
Kim. Like Kim said, that becomes a 3. Perfect, right? So knowing your place helps with the rounding, and you always look to the right, round up if it's greater than 5 to the right. 5 or greater, and then round down. Or not really round down, keep it the same as what you probably really said, but I know for many years we said round down because you're cutting those points off, and you keep everything to the right of wherever you're rounding, I'm sorry, the left of everything you're rounding the same, right? So just a quick refresher on rounding. And where rounding helps, and I know we're pushing our time limit here, but rounding versus estimating. So we rounded those things. So a way you can estimate, if I want to estimate 23 times 11, I can round those numbers. So 23 becomes 20, 11 becomes 10, and then I could do 20 times 10, which is 200. So 23 times 11 estimated is around 200. And then my actual answer would actually multiply 23 times 11, and I get 253. So when you go to 1.3 and Hawks is telling you to estimate, they want you to round both numbers. I personally don't care for that method. I would actually only round one of them if I was doing this in real life. If I had to do 23 times 11, I'd probably do 23 times 10 and get 230. And my estimate is at least a little bit better than 200. However, Hawks likes you to round both numbers. I don't test on that because I don't care for it. What my big takeaway I want you to take away from this is just understanding how to round and understanding how we can use estimate, wow, I can't even say the word, how we can estimate to get a close answer. So covered a lot today. I hope I've helped ease some of your anxiety for this class because I know it's new and some people were nervous. We'll start chapter 2 next week and we won't have all the admin stuff at the beginning.